Okay, now we're going to look at page 2, and this is actually the last page in the packet. This is all the characteristics or properties of a quadrilateral, just kind of broken down to what makes a shape a shape. So we'll start on the left here. Trapezoids are their own thing. They are quadrilateral, but they do not fall in the same category as like parallelograms, rectangles, rhombus. So they have a line here to separate them. So in a trapezoid, we want to focus on one pair of opposite sides or parallel. So that would be these, and these are called their bases. Okay. Consecutive angles are supplementary. If you remember from our chapter 1, this angle and this angle are called consecutive interior angles, which added up to 180. They're just saying the rules for parallel lines still apply inside of a trapezoid. A midsegment is something we don't really do much in this chapter, but it is a vocab word in some geometry books, so it's on here. A midsegment connects the midpoints of its legs. So if these things are called the base, this is called a leg, and this is called a leg. The legs are the non-parallel sides in a picture. Okay? So if you connect the midpoint here to the midpoint here, just showing that those two things are equal, that line is called the midsegment. The segment is equal to the average of the two bases. So like you could add this plus this and divide by 2 and tell you how long that middle line is. Like I said, I'm not really worried about that. You do need to know that this is called the base and a base, and this is called a leg and a leg. Okay. Isosceles trapezoids have more properties. They're more special. The non-parallel sides, which are called the legs, are congruent. Because of the word isosceles, this side is congruent to that side, meaning these are our parallel sides. That's what the arrows mean. These are congruent. Diagonals are congruent. So the length of diagonally connecting those corners and those corners are the same length. Base angles are congruent. So reminder, this is a base. So this angle is congruent to this angle. And the same thing up here, if the top is called a base, I'm going to show it with two lines. This angle at the top should be equal to this angle at the top. So not all four are congruent, but these two at the top are congruent to each other, and these two at the bottom are congruent. Opposite angles are supplementary. Well, if you think about it, if these two have to add up to 180, and this is the same size as that one, those two have to add up to 180. Okay? Alright, now let's look at parallelograms. A parallelogram has all kinds of properties on it. Opposite sides are parallel, so I can show that by putting arrows on the line. That's what I'm saying. Opposite sides are parallel. Opposite sides are congruent. We can mark that with little hash marks. So since this line's getting crowded, I'll just put one hash mark here and one hash mark here. Those two sides are congruent. And I'll put 2 on this one, so we know those two sides are congruent. So opposite sides are congruent. Opposite angles are congruent. So we'll show that if I put one mark up there, then that is going to be congruent to the mark down there. Those are considered opposite angles. And so this one down here, I'll put 2 lines, would be congruent to this one up there. Those would be opposite angles. So now, consecutive angles are supplementary. They write that on several of them, but that just means because these lines are parallel, consecutive interior angles add up to 180. So we don't mark that in the picture at all. It's just something to know because it's parallel lines. This is a key one here. Diagonals bisect each other. So remember the word bisect means cut in half. So in this picture I'm going to show that this side, I'll just put 3 marks on this one, should be equal to that side because that line is cutting this diagonal in half. So put 4 on that one to show that those two segments are equal. So key ones here, opposite sides parallel, opposite sides congruent, opposite angles congruent, diagonals bisect each other. As you can tell, there's a whole lot of things to memorize on this, so we are going to make some flashcards for these, just so you know. You'll notice that parallelograms, this is called a flowchart. So parallelograms are also these properties like a rhombus, if you want to write rhombus instead of rhombi. Everything on here was plural. So instead of saying rhombuses, they say it's a rhombi. So you don't say hippopotamuses. Anyways, probably a bad analogy. But so sometimes the plural form of like cactuses, cacti. So anyways, plural form, you have I at the end instead of S. That's an English thing, not a math thing. Just saying. This is a rhombus characteristics. So a rhombus includes all the characteristics of a parallelogram plus these three specific things. A rectangle includes all these properties of a parallelogram, but it includes these two special characteristics. So these are like the things that are more specific to make it a rhombus versus a parallelogram. In a rhombus, all four sides are congruent. So 1, 2, 3, 4. Okay? Diagonals are perpendicular. So where these diagonals meet at here in the middle, I'm going to put a little box to show that those are perpendicular. And you can put that box in any corner. Diagonals bisect the opposite angles. So you could say this angle is equal to this angle. So it's bisected. But here's the thing. It also said up here, opposite angles are congruent. So they're not only congruent, this angle and this angle, but they're also bisected. So all four of those little angles would be the same size. And the other direction, these four little angles will be the same size. Okay? And so we have four congruent sides, diagonals are perpendicular, and diagonals bisect opposite angles. On a rectangle you'll see the boxes in all four corners. That means you have four right angles. And diagonals are congruent. So that's kind of hard to show in the picture, but there is something special. Up here we said diagonals bisect each other, and the diagonals are congruent. So if you cut this diagonal in half, let's say that's bisected, but it's the same length as this diagonal this way, it makes all four of those segments the exact same length, which in turn creates these nice little triangles inside there, which are all isosceles triangles. Alright, the square, if we marked everything in the square, it would be a whole lot of characteristics, but a square has all the properties of a parallelogram, a rectangle, and a rhombus. So in the flowchart, parallelogram is like the least specific you could get. A little more specific, you could say it's a rhombus or a rectangle, and the most specific, or the one with all the characteristics, is called a square. Now, one that's not on this table that you may see depending on what book or worksheets or wherever you get your information is the word kite. And I'm sure you guys remember from like elementary school, what does a kite look like? Kind of like that, okay? That would be a kite. The only thing I want to add in information about a kite is it has these two sides are congruent, and these two sides are congruent. So they say consecutive sides are congruent. Another thing special about a kite, it has diagonals. If you draw on the diagonals here, these diagonals are perpendicular. Okay, so you have perpendicular. And let's see, one pair of opposite angles are congruent. So in this picture, now this angle does not look the same size as that angle, but these two on the side, this angle over here should be congruent to that angle over there. So you have one set of opposite angles congruent. They say consecutive sides are congruent, one's next to each other, versus like in a parallelogram it's opposite sides. And the diagonals are perpendicular. So, we joke about the flowchart. If a parallelogram and a kite have this quality and this quality, those two qualities make up what is called a rhombus. But kites aren't on a lot of things, so it's just kind of another shape that I wanted to mention. Alright, we are going to look at this, and I'm going to draw some characteristics in here on your notes, and you probably already have these in your notes. I just haven't uploaded this picture yet. So I'd have to picture on one line. Alright, so in this example, identify the most specific type of quadrilateral. So you would need to identify, okay, arrows mean parallel lines. In this picture, we only have one set of parallel lines. So we would call this a trapezoid, because it has one set of, I'll just do parallel lines. Okay, the quality or characteristic property, whatever you want to call them, of the second one is, I noticed it has 4 equal sides. Okay, so looking at your flowchart, you start at the top. Parallelograms don't have 4 equal sides, so I can cross that one off. Okay, so it's not a parallelogram, it doesn't have equal sides. So a rhombus has 4 congruent sides. So rhombus is the most specific I can go, because it doesn't have anything else marked in the picture. So rhombus is the most specific thing we can say. So again, it doesn't do everything in the picture, you're just trying to figure out the most specific. Always start at the top of the flowchart. Okay. So this one, the diagonals are bisected. But you'll also notice in this one, all 4 of them are congruent. So bisected would fall under parallelogram, but all 4 of them being congruent falls under rectangle. So this one, I would say diagonals are bisected and congruent. And that's why I went with rectangle. Okay, mark the unique characteristics of the following quadrilateral on the given quad. Okay, so in a rhombus, what makes a rhombus more special than a parallelogram or different than other things? So I'm just going to go to my flowchart and mark these 4 things, or these 3 things. 4 congruent sides, I need to mark that. I need to mark diagonals are perpendicular, and we need to mark diagonals bisect opposite angles. So we just want the most specific thing for that particular shape. So those would be everything I would be looking for in the rhombus. Isosceles trapezoid. It says non-parallel sides are congruent. So on a trapezoid, I do want you to always mark your parallel sides, so I know that this is not my parallel side. Those are congruent sides. Those are called my legs. Diagonals are congruent. You could just kind of do that to show that that side is going to be congruent to like this side. That's kind of one way you could show it. It says base angles are congruent, so maybe if these are my parallel sides, I'm going to call this a base angle and this a base angle. So you'll notice on all these pictures we have right now, they all look like squares. The idea is we're not checking that you can recognize a shape now, we're checking that you can identify the properties of a shape. So not looking at what in general looks like a rhombus, but okay, what property includes 4 congruent sides, or what property includes 2 diagonals that are congruent and bisected. So we're looking beyond what it looks like and looking for properties. Alright, moving on to polygons. Polygon is a closed figure with straight edges. So like a circle cannot be considered, or a semicircle cannot be considered a polygon. So concave versus convex, just kind of a general picture here. This would be called concave. A side is caved in or dented in the side. Convex is one we are more used to, like this would be convex, where all the angles are on the outside. So the way the book definition, the difference is concave means that if you were to connect a corner, any corner, that one side is like caved in. The diagonal for that side would be on the outside. Whereas on these, if you connect any corner here, the diagonals for those would all be inside the shape. Okay? A regular polygon is equilateral and equiangular. Which means all sides are equal and all angles are equal, so we know all the angles are the same. So naming polygons, this is going to be something you're going to want to know the names of, so you need to memorize this list. Okay, important to know these names. 3 sides is a triangle. 4 sides is called a quadrilateral. 5 sides is called a pentagon. 6 sides is called a hexagon. 7 sides we call the heptagon. Somewhere in elementary, some people also called it a septagon, and that is an option, but in geometry books they always call it a heptagon. So 8, octagon. These are all polygons, so it all ends in like the gon on those. 9 is a nonagon. 10 is a decagon. 12, dodecagon. So 11 is one that we don't use. Somebody asked me one time what it is. It's just a hendecagon. It's not commonly used, so 11 sides is kind of an odd one. We could keep going, but this is the list. We want you to know what those words mean. So if you have like 23 and we don't know what 23 is, 23 you just say n is the number of sides, so you would call it an n-gon. So let's see, if you say a 23-sided figure, we're going to call it a 23-gon. So if we don't have a specific name, but again, these are the ones we want you to memorize. Okay. Interior angle sum. I'm attaching a little clip to this. It's called like interior and exterior angle theorem. It's on mathisfun.com website. It kind of shows you where these formulas come from. But the interior angle sum comes from n minus 2 times 180. It's 180 degrees because if you take any shape, any polygon, and let's say I'm going to draw a line to each corner of that polygon. Okay? So this had 1, 2, 3, 4, 5, 6. That's 6 sides. But if you look at that, when you connect the corners, it creates 1, 2, 3, 4 triangles. So the n minus 2 is the number of sides minus 2, and then take that answer times 180 degrees because by creating those lines, we've created 4 triangles here, and each triangle is 180 degrees. So 4 times 180 would tell me how many degrees that whole interior angle sum is. Exterior angles always sum to 360 degrees. Again, if you watch the little Math is Fun video clip, it'll show you the exterior angle theorem and why that works out every time. Alright, let's look at the last page. I'm just going to do it with this one. It's filling in polygons, regular polygons. Remember, a regular polygon means all the sides are equal and all the angles are equal. So we're just going to start with the name of a 5-sided figure is called a pentagon. The interior angle sum, I'll write that here, is n minus 2 in parentheses times 180. So if you take and do 5 minus 2, and you don't have to show this work, I'm just writing it down so you know what I'm doing. 5 minus 2, 1 times 180, that would be 3 times 180. 3 times 180 is 540 degrees. So if you add up all the interior angles of a pentagon, it should be 540 degrees. An individual interior angle means you're going to take n minus 2 times 180 And if you want just an individual, just one angle, you're going to divide that by the number of sides. So for this one, we would take 540 divided by 5, because there are 5 sides in a pentagon, or 5 angles. And 540 divided by 5 is 108 degrees. So this is the formula for that. Individual exterior angle is 360 degrees. And you want just one of them, so you're going to divide them by n because they're all the same amount. So 360 divided by 5 equals 72 degrees. One thing I want you to notice when you get done with that, these two answers, I'm going to highlight them. Those two answers, the interior angle and the exterior angle always equal 180 degrees. And I'll show you a little picture up here. If this is, we'll say, inside my shape. This is not a good shape, but this would be like the interior angle. And this out here would be considered the exterior angle. The interior angle and the exterior angle add up to be a straight line. That's why this interior angle plus this exterior angle are going to equal 180 degrees. Just so you kind of know that, okay? Just a good way to check your work. This one, I don't know how many sides it is, but I can work backwards. We know that this is 150 degrees, okay? So in order to just trying to get my thoughts here. Interior angle. We're going to set up an equation to solve. So the formula here is okay, so I took whatever the formula is for that column. That's the formula for interior individual angle. And we need to solve. Solve for n. To solve for n, you would times n to the other side. Okay. To get rid of parentheses, you distribute. And then you gotta get your n's on one side, your numbers on the other side. So I'm gonna just do this in one step. I'm gonna subtract the 150 over here, but then I'm gonna add the 360 to that side, just because I like positive numbers. Okay, and then you could divide both sides by 30 to get the n. So n equals 12. So that's like the biggest, longest, hardest one to solve. But I was just using the formula for that column, or for that specific thing, and I set it equal to the number given. So this one was n equals 12. So over here I'm going to say this is a 12-sided figure. That's a dodecagon. If I want to just do this part here, n equals 12. So 12 minus 2 times 180. 10 times 180 is 1800 degrees. And the last one, you could do this either way. You would take 180 minus 150 to figure out this is 30 degrees. Or you can take 360 divided by n. So 360 divided by 12, because we said it has 12 sides, would be 30 degrees. Alright, this time they give us this column. This column is interior angle sum is n minus 2 times 180 equals 3,780. So, two different ways you can distribute. Most people like to distribute, so we can do it that way. by distribute, you'll add 360 to the other side. Calculator for that one. Okay, and then divide by 180. And I got 23. So the answer for this one here would be 23 sides, which just happens to be the one I used on the other page. We don't know what 23 is, so we're going to say 23 gone. And an individual one, you're going to take this amount and divide it by the number of sides, because that's the interior sum. So 3780 divided by 23. This one comes out to a decimal. They don't always come out nice and even. So we'll round it to about 164.3. Okay? And then this is 360. It's always 360. And then divided by the number of sides. It's 15.7 about. Okay, again, you'll notice even though these were decimals, these two numbers should still add up to 180 degrees. So this last column is really just a review. What do you call it when you don't know how many sides? We call it an n-gon. These are like just the formulas. So interior angle sum, that formula was n minus 2 times 180 degrees. That's based on how many triangles you can make out of the shape. Individually, you would divide that by the number of sides or angles. It's the same. N divided by the number of sides to get an individual, just one of them, because they're all equal because it's regular. And the last one was 360 divided by n, because exterior sum's always 360, so you just divide it by the number of sides in order to figure out the individual exterior angle.